No, it's okay. Okay. Thank you very much. I was thinking how I can explain my adventure trying to make a new CPE for IPv6, and I was thinking, okay, it looks like the film that everybody knows, right? So that's the reason for this presentation. So you can read either way, Raiders of the Lost Ark or In Search for the Lost CPE. So just like Indiana Jones, you know, if you have tried to deploy IPv6, if you are an ISP, you know that one of the major difficulties to get IPv6 deployment in an ISP network is the lack of good IPv6 support for the CPEs. When I say CPEs here, I can use CPE or CE is the same. It means the small cost router that typically residential or SMEs have, not a big router, okay? So the problem is basically that we are trying to deploy either dual stack, and yes, maybe we have CPEs that support dual stack, or we need to use some transition mechanism. And this is unfortunately most of the time in most of the networks, especially when running out of IPv4. And then we don't have CPEs that support all the possible transition mechanisms, among other reasons because there are too many transition mechanisms, so that's difficult to decide. But that's a topic for another presentation. We can speak about 2 hours about that, right? So what happens is that in 2011, we had a document from ITF, which was RFC 6204, which was describing the situation and what are the requirements for an IPv6 CPE, and that document was updated a few years later in 2013 with 7084, which is the actual document as a reference for a CPE builder to support IPv6, right? The thing is that this document is only supporting partially what is the actual need for IPv6 support. Because mainly this document is only thinking in dual stack networks, but we know we don't have any more IPv4 addresses, so we cannot do any more just dual stack. There is another problem here, and the problem is that big ISPs, and I am not sure how many big ISPs there are in Africa, maybe Liquid Telecom is one example, it was mentioned this morning. They have the power to tell the CPE makers, do for me this. So they take a standard CPE and they define a specific features for the software or the firmware that they want in the CPE. But most of the ISPs, and that's happening not just in Africa, also in Europe, that there are many small ISPs, or in Latin America and many other regions, Asia Pacific as well, they don't have the power to tell the vendor, I need this. So they need to go to the local market, sometimes to the supermarket, because they buy 10 CPEs for this week. They don't buy 1,000 CPEs every month, okay? So they don't have the power to require to the vendor, I need this for my network. So that's one of the problems, of the hassles that the small ISPs have to deploy IPv6, and that means also that there is a lack of pressure to the vendors to actually make these CPEs that can run in any network. So that means also that an ISP may buy this week this model, next week that model is no longer available, I need another model, and next week another one, and that means more expensive operation and management of your network, because you cannot just have a single platform to manage all the CPEs. So that's getting very, very complex. Surprise, we don't have any more IPv4 addresses. Okay, so we all know that. So we cannot run anymore dual stack. We could do dual stack with carrier by NAT. We could do with private addresses for the one of the CPE, but that's really, really, really expensive. You mean to spend a lot of money in carrier by NAT boxes, and what is going to happen is that once those carrier grade NAT boxes have a specific IPv4 public prefixes running with online gaming, for example, PlayStation Network, PlayStation will block your IPv4 address. Okay? They will put your blocks in a blacklist, and they don't remove you from the blacklist. You can pray, remove me, they will not do that. Okay? So that means you need to stay rotating your IPv4 pools until all of them are in the blacklist. So then, in addition to have spent money in carrier grade NAT boxes, you need to spend money in buying new IPv4 addresses. So buying carrier grade NAT boxes is not a good idea. Just go directly to buy addresses in that case, because they will become useless after a few months, because PlayStation and other, for example, OpenDNS and many other services around are already blocking any IP blocks that they realize are behind carrier grade NAT, because the services don't work. So they don't want to have a bad name because the game is not working. Okay? So they put the blame on the ISP. So there is no sense in to go into this direction. So we have the ITF going to the rescue. And the idea was a few years ago already, and started that with cellular networks, but as well for broadband networks. Let's look into a new set of transition mechanisms, not anymore relying on IPv4, not anymore relying on things like 6RD or dual stack, but look into having our network, especially our access network, the last mile, which IPv6 only. So we have IPv6 only, we can run IPv4 on top of the IPv6 only network, which that means is cheaper for the ISP because they are managing only an IPv6 network, and for all the devices behind the CPE, they don't realize that they don't have any more IPv4 because there is a transition mechanism solving the problem for them. Okay? That's what we call IPv4 as a service. Problem, we are not yet done, because those transition mechanisms which were invented already 3, 4, 5 years ago, they have good support, at least one of them in the cellular networks, but the CPEs don't have the support for those transition mechanisms. So that was basically the start of my work on this field, thinking we need to update RFC 7084, which is the specification for the CPEs with IPv6. We need to make sure that this document includes the new transition mechanism. So I started with this work almost 3 years ago, more active in 2016, and then I convinced the ITF working group, B6 Ops working group, in March 2017, yes, we go for it, and my document was adopted as a working group item. But then I got people from the previous document pushing back. No, we cannot change RFC 7084, is to all, we need to keep it, it's already supported, we will break things if we change that. So at the end, I started working in many different possible solutions to that hassle, and at the end, I succeeded last August to have, instead of updating this document, making a new document which is complementary to the 7084, which at the end is the same, but the people like it this way, which went to the last call. Last call in ITF is when a document is going to become an RFC, unless somebody complains that there is something really broken. Nobody complained, so now we are in the process that it's slow. It may take still a few more weeks. I guess it may be my Christmas present, maybe, because I think it will be around that time that it will get an RFC number. So what is the idea of this document? More or less, I think everybody got the picture now. The idea is to make sure that ISPs can go to the market, can buy any CPE supporting this document, and it will work in any ISP network. So no need to have different management options from different models for different ISPs, for different vendors. You just buy a CPE and it has support for all the main IPv4 as a service transition mechanism. Okay, so that's the idea. If you want to look for the document right now, you need to look for this reference here, draft ITF v6 ops transition IPv4 as a service. At the beginning, I was alone doing this. I convinced a couple of good or well-known vendors. You know probably D-Link. D-Link is now one of the co-authors of the document, also NAC. NAC is a Japanese vendor. Maybe they are not selling CPs in this region, but in other regions they are also popular. So again, this document is not a recommendation for the ISPs to use one or the other transition mechanism. It's a must for the vendors to support all of them. So the ISP still can make the decision of what you prefer to use on your network. I can give you hints about what is the best one, but that's out of the scope of this presentation. But at least you know that whatever model you buy, you say the vendor, I need to support this document, and that means it will run in your network. And if your customer needs to buy the CP by himself, he can move to another ISP and it will work as well. Okay, so that's good for you and it's good also for competition. If you are a vendor, obviously you need to make sure that you support the document and you support all the transition mechanisms. If you are a vendor and you are selling directly to a specific ISP, you don't need to support this document. The ISP is going to tell you what he needs. But if you want to sell the CP in the supermarket, let's say, or in the general distribution market for TI, then you go to acknowledge that you are following the document. I am not sure how we are with the time. Somebody can tell me how much time I have yet? 10 minutes? Okay. Because I don't want to enter in all the technical details. If we don't have time, you can have them in the presentation. I think I provided already the slides, so they should be uploaded in the agenda or whatever. So you can look at the details later. So I am going to just go into the main points, right? One of the ideas is there are a few transition mechanisms to be supported, and one of the ideas is the CPE must be able to detect automatically what transition mechanism is being used by that ISP. This way, the ISP don't need to configure anything. The user don't need to configure anything. So we are trying to make it as easy as possible, okay? And basically, it means plug and play. If the ISP is doing correctly his work, if the ISP is setting the parameters in the network so the CP can detect what is working on that network, that will just work fine. That's the idea of this document. So there are a few requirements. Those are general requirements for any CPE supporting this document, and then there are 3 configuration steps. So the ISP also can control the CPE in case if the ISP is supporting several transition mechanisms, for example, for different type of customers, maybe residentials, maybe SMEs, maybe corporate, they can have different transition mechanisms in the network, and they can say to the CPE which one they want to use without needing to configure anything at the CPE level, okay? It will be done automatically. So what are the transition mechanisms that we are supporting? We are supporting 464X-LAT. If you ask me a recommendation for which transition mechanism you need to support, I will tell you directly go for 464X-LAT. This is the transition mechanism that has more support right now in general in terms of global IPv6 deployment, because most of the cellular networks use 464X-LAT. In fact, 464X-LAT is the only transition mechanism that is supported in the cellular networks. No other transition mechanism got supported except, of course, dual stack. Okay? So, especially if you have in your network support for cellular and broadband, you go for 464 slot. You don't want to go to different transition mechanisms for different parts of your network. It's easier to have a single one, especially if you will have services like fiber or DSL and then a backup link with 3G. You don't want to have in the different interfaces different transition mechanisms. So that will be my suggestion. But again, it depends on every specific network. Just in case, we also have support for DS Lite, Lightwave 4/6. Lightwave 4/6 will be my decision if you, for whatever reason, don't want to do 464X LAT. And then additional alternatives are MAP-E and MAP-T. And as said, I have specific slides for every one of the transition mechanisms. I am not going to go to the details. You can read that later on, and I am here still tomorrow, and after tomorrow you have questions, you can catch me. Let me see if there is anything else really important that I should talk about. I don't think so. Well, yeah, there are other requirements which are not, let's say, specifically related to transition, but somehow one of them is the support of multicast. What happens is that many service providers today, which IPv4, they do IPTV, which IPv4 multicast, okay? If you go to an IPv6 only network, maybe your IPTV system is still not supporting IPv6 multicast. And to make sure that it keeps working, we have put also a must for the support of specific features for this multicast of IPv4 on top of IPv6. So it will be transparent for you. That's the situation. There is a specific section also for requirements for UPnP, especially for security reasons, okay? Because today, a CPE in IPv4 and a CPE supporting IPv6 need to have a firewall. NAT is not security, it has been said this morning. You need to have NAT in IPv4, and you need to have, in addition to NAT, a firewall. It's true that sometimes they are, let's say, more or less the same thing in terms of what the user can see, but inside there are different things, okay? And in terms of IPv6, you don't have NAT, so you need to make sure to have a firewall. And if you want applications to be able to control the firewall, the way to do that is using UPnP. So there are specific requirements for that. So the users can have the chance to also say, I want to have this service inside my network and want to expose it outside, etc., etc. And the last thing is, because 6RD is based mainly in public IPv4 addresses, we don't support it anymore. So that's one of the differences between this document and RFC 7084. Some people was complaining, how you are going to support 5 transition mechanisms with a CPE? Look, if you have a CPE, which most of the time is a Linux box, most of the time is based on OpenWRT, supporting all the 5 transition mechanisms means typically an increase of only 10 or 12 kilobytes of code. That's nothing. So even a CPE which is 10 years old, 15 years old, today you can grab it, flash it again, instead of using the original firmware which OpenWRT, and it will support IPv6. There is no lack of performance or anything like that because running IPv6, okay? So that's what we are answering to the people that complains that I cannot support it. And in fact, my co-authors from NAC and D-Link and other vendors I am working with, they already support all these transition mechanisms and they are selling it. So it's a demonstration that what we are saying is true, and it's not they are selling a new model. They are selling the same models as 2 or 3 or 5 years ago with the support all of this. So as Indiana Jones was looking for the lost ark, we finally found our lost CPE for an IPv6 only internet. So again, if you are an ISP, make sure to look into this document. Hopefully soon, matter of weeks, maybe before end of year, for Christmas, for New Year celebration, it will be an RFC, and then you should state in your tenders to your CPE providers that they need to follow this document. That will make definitively your life easier and will save a lot of money to you deploying IPv6. And that's it. Thank you very much. Questions? Any question?
There's one question from a remote participant, Willie Manga, speaking in his personal capacity. So from question to Jordi. So from your talks with D-Link and the other vendors, when do they intend to provide CPE following your recommendations? And he has a remark, they should look carefully on default firewall rules.
Okay. Actually, the co-authors that worked with me with this document, together with other companies, not only this one. For example, another one I remember that committed to do this as well is Sixel. I am not sure if Sixel is popular in this region. They are already supplying CPEs following this. Okay. The thing is that at the moment, the freeware that they deliver with the standard models in the let's say in the supermarket, in the retail market, it's not following still this. But if you are an ISP and you talk to your reseller or local distributor for those, they will provide it to you. When they intend to go to the general market with this support, I cannot say. I think it's difficult to predict because that's sometimes a marketing decision or a commercial decision. But I really hope that once we get an RFC number and they start feeling the pressure from the market, from the ISPs, they will do immediately because it's ready. The code is there. It's just providing it to in the default factory build, right? So again, my suggestion is put the pressure in your providers. Make sure that they deliver CPEs with this support. Done? I am in the middle with the break, I guess. Thank you very much. Oh, another one.
Well, I particularly prefer getting my equipment.
Sorry, give your name and your organization.
My name is Daniel from Nigeria. I said I will prefer buying my equipment instead of tying myself to an ISP equipment. So, and I will think most people will want to do that. So I think the idea of having ISPs supporting open architecture network infrastructures will be better, so that users can actually go to the market, pick any device, just as you said with D-Links, and every other devices that can support that. That would be better than tying yourself in with the ISPs.
That's precisely what this document is doing.
Yes.
This document is mandating the vendors to support all of them. So when you buy a device, if you are an end user instead of an ISP, you buy a device in the supermarket, you get all the support. So it works with ASP A, ASP B, ASP C, and so. Yeah, okay, so that's the thing.
Yeah, so that means if the vendors are producing those kind of equipments, it makes the ISP or force the ISPs to be able to move faster. That's, I agree with what you said.
It's good for the ISPs, it's good for users as well. Thank you. Thank you.